Hello students and seekers of truth. In this video, we will begin to study something called combinatorics. And that's just a fancy word that means counting. Okay, but these are principles of counting, and I'll show you in just a minute how counting is actually much more complicated than we think it is. At least it is trickier than we think it is. So let's start with this nice small little example with 3 people decide to race each other. How many ways can they finish first, second, and third? All right, now let's do this the old-fashioned way. We call it the brute force way, but we can just list out the 3 people. So let's just, for the sake of brevity, let's just call them A, B, and C. And here is one way that they can finish, A, B, C. Here's another way that they can finish. A can finish first, C can finish second, and B can finish third. Okay. Just going to change my colors up here. Here's another way that they can finish. We can say that B could finish first, then A can finish second, then C can finish third, then B could finish first, C could finish second, then A can finish third. So we see already there's 1, 2, 3, 4 different ways. And one more way here, let's list this out. Let's say C could finish first, and A can finish second, and B can finish third. Then C could finish first, B could finish second, then A could finish third. Okay. So altogether here, we see that there are 6 ways. Okay. So now that answers the specific question, but let's extend this idea and let's try to organize this in some ways so that, let's say we had like 20 people, we could find a way to calculate it without having to list out all possibilities. Okay. And this part of mathematics, combinatorics or counting, it's really about visualizing and trying to understand how to organize information. And there's always more than one way to solve the problem. What's really important is that you find a particular way that you can make sense of it. And then if there's other ways you see, you try to connect the 2 ideas together as best you can. So one way that I like to do this is using something called a tree diagram. It doesn't actually look like a tree exactly, but it's close. So let's start with a singular dot. We call this the root of the tree. And then we ask the question, how many people can how many different ways can people finish a race? Well, let's just think about the different ways to finish first. There's 3. Either A can finish first, B can finish first, or C can finish first. Okay, so this is the first level of the tree, first place, right? Now, after A has already finished, there's only 2 choices for second place. So B can finish second, or C can finish second. Okay. Or if you look at the next scenario, if B finished first, then it's either A or C. And if C finished first, then it's either A or B. Okay. Finally, when we look at our third place, well, if A and B already ran, then only C can finish. If A and C ran, then only B can finish. And we can fill out the rest of the tree in the same way. And now if we go through and we look at this tree, or like each path down the tree, A, B, C, that's one way. This is 2 ways. This is 3, 4, 5, and 6. Okay? And we can, these ordering matches the list that we've made up here. But writing it this way, see how it's kind of like an upside down tree where it's getting wider as we get towards the bottom. But when we look at it this way, we can see that there are 3 ways for people to finish first. For each of those, there's 2 ways that they can finish second. And then for each of those, there's 1 way for them to finish third. Okay, so 3 times 2 times 1, that's equal to 6 different ways. Okay? So there you go. This is your introduction to counting or combinatorics. Okay? People running a race finish first, second, and third. Now let's investigate a new scenario when we have more people. All right, now let's say there are 9 people in the race. How can they finish first through ninth? Now you can see here, if we start to list this out, A, B, C, D, E, F, G, H, I. Okay, so that's 9, the first 9 letters of the alphabet. And it's like asking, how do we possibly rearrange all 9 of these so that we get some all the different possible combinations? And that's very, very difficult. Okay, so let's consider our tree diagram. To finish first, there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 different branches, right? Then to finish second, there's going to be 1, 2, 3, 4, 5, 6, 7, 8 different branches coming out from there. And so for each of these red branches, there will be 8 of these purple branches. And then if we keep on going, for each of those purple branches, there will be 1, 2, 3, 4, 5, 6, 7 of these blue branches. And so you can see how this gets multiplied. There are 9 different people who can finish first. Whoops. Not sure what happened there.
Pardon the interruption, faculty.
So, sorry, let's do it again. 9 different people who can finish first. Right. And then for each of those, there's going to be 8 people who could finish second. So that's all of the purple branches here. And then for each of those, there's going to be 7 different people who can finish third. And then 6 different people who can finish fourth. Then 5 people who can finish fifth. Then 4 people who could finish sixth. Then 3 different people who could finish 7th, and then 2 different people who could finish 8th, and then of course there's 1 person who's going to finish last. So 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, whatever that answer is, that's going to be the different ways that people could finish 1 through 9. Now, we define a new idea here. We call it a factorial. That's 9 with an exclamation point, so that's pronounced 9 factorial. Or if we say n factorial, that just means n times n minus 1 times n minus 2 times n minus 3, all the way down until eventually you get to 1. Okay? So that's the number of different ways that people could finish first through ninth in a particular race. Okay? So that's, in this particular case, with 9, it is 362,880. And you can see how difficult it would be for us if we had tried to list out all the different possibilities. We'd be here a long time, right? With 3 people up here, with 3 people, there's only 6 ways. With 4 people, there would be 24 ways. And when we get up to 9 people, we're up to over 362,000 ways to rearrange this. Okay, so there you go. Here's a brief introduction into the world of combinatorics, or advanced counting. We'll continue in the next videos with slightly more complicated examples. Thank you for watching, and have a wonderful day.